Hey there, chemistry students. This is Ms. Ruark. This is the podcast that shows you how to answer or gives you the correct answers to your electrons and periodic properties review. Okay, so I did notice after I gave this to you and we started looking at it and Leah came in and talked to me that there are questions on here that deal with periodic trends, and we're not testing on that just yet. So I will answer those questions so that you have them and you can study over them, but you don't need them until you take the test on Friday. All right, so let's go through these and make sure that we have the right answers for them. So the first one says to complete the shorthand configuration for the following elements. Now remember, shorthand is the same thing as noble gas configuration. So you need to find your element on the periodic table, which would be nitrogen. You go up one row and all the way to the right, and that would give us, we can write in red, sure. No, I don't want to write in red. I don't want to write in red. Okay, blue. All right, so we go up and all the way to the right, and you should have neon. Sorry, wrong element. You're going to have helium, and then you're going to finish in with 1s. Oh, goodness gracious. I'm sorry. 2s2, 2p3. All right, for strontium, up and over, you should have krypton, and then you should have 5s2. For selenium, you would go up and over, so you would have Ar in brackets. And to get to selenium, we would fill in with 4s2, 3d10, and then 4p4. All right, and then the last one we have manganese. Up and over we have Ar in brackets, 4s2, 3d, 1, 2, 3, 4, 5, 3d5. All right, so far so good. Okay, Lewis electron dot. So if we call for the Lewis dot or the electron dot or the dot diagram, anytime you hear the word dot in it, you know that you're going to be drawing the symbol and filling it in with dots around it, right? Oh, yeah, I remember that. Okay. So magnesium is in group 2, which means it has 2 valence electrons, so we draw 2 dots. Aluminum is in group 13. It has 3 valence electrons, so you'll draw 3 dots. Carbon is in group 14. It has 4 valence electrons, so we draw 4 dots. Arsenic is in group 15. It has 5 valence electrons, so we draw 5 dots. All right, oxygen is in group 16. It has 6 valence electrons, so we draw 6 dots, 5 and 6. And then chlorine is in group 17. It has 7 valence electrons, and therefore we will draw 7 dots. Oops, I drew too many. I got real happy on that. I was just dot happy for a second there. Okay, there you go. So you have 7 dots around it. All right, answer the questions based on the following configuration. So first off, they want to know what's the name of this element. Well, if we look at Ar 4s2 3d10 4p3, that right there, 4p3, 1, 2, 3, should be arsenic. A-R-S-E-N-I-C. Okay, is it a metal, is it a metalloid, or is it a nonmetal? Well, if it's a metal, it's on the left-hand side of the staircase. If it's a nonmetal, it's on the right-hand side. And if it's a metalloid, it's touching. And it is touching, so we say it is a metalloid. All right, group name. Well, it is in group 15, but I didn't really give you a name for it, so you don't have to give me one. But if it's really bugging you, you can call it the nitrogen family. All right, and then the dot diagram for it. Well, arsenic is in group 15, which means it has 5 valence electrons, so we draw 5 dots. There we go. All right, name of element 4s1, that's going to be potassium. It is in group 1, which is the alkali metals, which means that it has to be a metal. If you get that wrong, ooh, I feel bad for you. All right, potassium is in group 1. It has 1 valence electron, and so its dot diagram would be K with 1 dot. Okay, on the next one, 3s2, 3p5. We're looking at, my pen just stopped writing. Here we go. Oh, no, it doesn't want to write anymore. All right. No, go back. Technical difficulties, sorry. All right, chlorine. Metal, nonmetal, or metalloid? It is a nonmetal. How do we know? Because it... What are you doing? I'm not even pushing the buttons. It's a nonmetal because it's on the right side of the periodic table. It's a gas, and gases can't be metals. All right, what group is it in? It is in the halogens. And the halogens have 7 valence electrons, so chlorine is going to have 7 dots. Okay, now you can go to the next slide. All right, which two elements have a configuration exception? So which are the two that I told you to remember? That would be copper and chromium. Okay, copper would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10. Remember, it had 9, but one of those lines was just a little booger and wanted to whine and cry, and so 4s decided to donate one of its electrons. How sweet. All right, we're doing that to lower the energy level. Remember, we're lowering the potential energy. All right, and then chromium was the other one, 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. Those are the only two that you need to know. Okay, describe the relationship between wavelength, energy, and frequency. Okay, so if it has a wave like this, and if it has a wave like this. All right, wavelength goes from crest to crest or from trough to trough. The longer the wavelength, remember upside down Y is wavelength, the longer the wavelength, less the frequency, which is going to give us less energy. If it has a shorter wavelength, it's going to have a greater frequency, which means it's going to come around more, and it's going to have a greater energy, because in order to come around more, it has to have energy to get around. All right, what are valence electrons? Those are the ones in the outside, the outermost electrons. All right, number 7, what is the maximum number of valence electrons you can have? 8. Remember the octet rule? 8 valence electrons, no mas. All right, number 8, which elements are more electronegative? Elements closer to the noble gases or further away? Well, remember, electronegativity is the sharing of electrons. It's the pull on shared electrons. All right, so the elements, as you go across the periodic table, we said that the electronegativity increases, so it becomes more electronegative as you go across because, do you guys remember? Because you're increasing the nuclear charge, which increases the Coulombic attraction, which makes the size of the atom get smaller, and if it's holding those electrons in closer, it's harder to pull them away. All right, so more electronegative as you get closer to the noble gases. Number 9, describe atomic and ionic radius as you move down the periodic table and as we move across the periodic table. So atomic and ionic radius, both of them dealing with the size of the atom, size of the ion, and we said as you go across, the size gets smaller. Why? Because there's an increase in the nuclear charge, which does what to the Coulombic attraction? It increases the Coulombic attraction. Coulombic, I spelled it wrong all those days in class. C-O-U, Coulombic, not Coulombic, Coulombic attraction. And if it is pulling, increasing that Coulombic attraction is going to make those electrons on the outside get closer. All right, what happens as you go down? Well, as you go down, it gets bigger. Why does it get bigger? All right, as you go down, you're adding more layers, more energy levels, more energy shells. As you add more energy layers or levels, the distance from the nucleus to the outside electrons increases. And as it increases, it's going to decrease the Coulombic attraction. And if it decreases the Coulombic attraction, it's going to hold those electrons a little bit further away from it. Why does it have a decreased Coulombic attraction? It's due to shielding. Remember, those inside electrons are repelling those outside electrons away. All right, these right here, 8 and 9, are both on the periodic trends quiz, or test, excuse me. I'll explain that in class. All right. Number 10, this is on the test as well on Friday. What is electronegativity? I just told you. It's the pull on shared electrons. Pull on shared electrons. Label the number of orbitals for the following. So the S sublevel has 1 orbital, the P has 3, the D has 5, and the F has 7. Remember, those are the dashes. 1, 2, 3, 1, 2, 3, 4, 5. That's why we call it orbital notation. Yes. What is the lowest energy state of an atom? That's called its ground state. Ground state. What is the highest energy state of an atom? That's called its excited state. Oh, how cute is excited. Number 14, off-ball principle means filling up. So you're going to fill the lowest energy levels first to the highest energy levels. Lowest to highest. Describe the Pauli exclusion principle. That means if there's 2 electrons in an orbital, they must have opposite spins. Opposite spins. All right. Describe Hund's rule. This is the one where I tell you each one gets one, then the pair. Each one gets one, and then you go in with your second electron. All right. Number 17, determine the errors in the following configuration and tell the rule or rules that are being violated. All right, so everything's good. This is 1s, this is 2s. We're looking good. This is 2p, this is 3s. Wait a minute. There's only one electron in here. Oh, and there's 2O in here, and it's just bad. All right, so what's the rule that's being broken here? Well, that would be the off-ball principle, because you have to fill from the lowest energy first, which means the 3s has to be filled before the 3p. Also, you're not obeying Hund's rule. Why are you not obeying Hund's rule? Because each one gets one, and then they get their second. You can't give 2 to the first one. That's not fair. The other 2 are crying now. Mommy, she stole it. Okay, enough of that. Sorry. All right, and then we also broke the Pauli exclusion principle. Guess what? We broke all 3 rules. Why? Because Pauli says that if there's 2 electrons in an orbital, they have to have opposite spins, and those don't have opposite spins. They're going the same way. All right. Number 18, where are these located at on the periodic table? And this will be on the periodic trends test on Friday. So halogens are in group number 17, right before the noble gases. Your alkali metals are in group 1. Your alkaline earth metals are in group 2. Your metalloids are touching the staircase. They are physically touching the staircase. Yes, don't say they're in the swimming pool, because that's wrong. They're touching the staircase. The swimming pool is your transition metals, right? Noble gases, that's going to be group. Oh, it doesn't want to work anymore. It's getting all disgruntled on me. All right, that's group 18. All right, what are the horizontal rows on the periodic table called? They're called periods. Okay, what are the vertical columns on a periodic table called? Those are the groups or the families. Okay, and why are they all groups or families? Why do we call them a family? Because they have similar characteristics. So as you go down a group, they have similar characteristics. And the reason, or why do they have similar characteristics? Because they have the same number of valence electrons. It's the number of valence electrons that makes them behave the way that they do. It's not what the rest of the junk that's in them. It's how many valence electrons they have. So all of these in group 1 have 1 valence electron. So they're all going to behave the same, well, similarly. Not the same way, but similarly. All of these here in group 13 have 3 valence electrons, so they're going to behave similarly. All the noble gases have full valence electron shells, so they behave the same or similar. All right, answer the following questions based on the following configurations. So for this one right here, for 5p5, that would be iodine. That's the one that we're looking at. It is iodine. It is in period 5. It is in group 17. It's in the halogens. And then when it says block, that's like what sublevel is it in? SP, D, or F, it's in the P sublevel. How would it become more stable? By taking 1 electron. So it can be just like the noble gas next to it. What charge will the ion form? A -1 charge, because it takes 1 electron. It is a non-metal, and the name we've already said. All right, let's choose another color. I hope I'm going to have enough time to do this. Purple. All right, on this one, this is potassium. Oops, potassium. I'm going to run out of time. It's in group 1, it's in period 4. It's in group 1. It's in the alkali metals. It's in block S. It would become more stable by losing an electron. It would become +1 charge. It is a metal, and we already said the name, and I'm running out of time. Let's make sure we go through these real quick. The following order of decreasing atomic radius. Hold on one second. Okay, these are both on the periodic table trends quiz or test that's going to be on Friday. These are the answers for them, putting them in order decreasing, meaning goes from big to small. And the same thing on this one. If you have questions, let me know when you come into class, and I'll see you in class.